Welcome to the Satish Dhawan Space Center of ISRO, the spaceport of India, located at Sriharikota, the very special spindle-shaped island on the east coast of India. Located by the beautiful Pulicat Lake, SDSC Shar is now fully geared for launching PSLV C-41 IRNSS 1I mission. The rocket is now getting ready to launch 1.4-ton navigation satellite, IRNSS 1I. This satellite shall be the latest addition to the constellation of IRNSS satellites already in orbit. The launch will take place from the first launch pad of SDSC Shar, made primarily to launch PSLVs. It was built on the concept of integrate on the pad, in which the individual stages of launch vehicle are stacked one over the other on the launch pad itself. The Polar Satellite Launch Vehicle of ISRO is a 4-stage launch vehicle system. It is 44 meters tall and is 2.8 meters in diameter, with a lift-off mass of around 320 tons. It is capable of launching 1.7-ton satellites in sun-synchronous polar orbit and 1.4-ton satellites in sub-geosynchronous transfer orbit. Let us go through some steps of rocket assembly. The first stage, PS1, also called the core stage, is first to be integrated. PSLV uses the S139 solid rocket motor in the first stage. This 20-meter long stage uses around 138 tons of solid propellant. To generate the required lift-off thrust, this XL version uses 6 large strap-on boosters which are attached to the core stage. Each booster is 12 meters long and uses 12 tons of solid propellant. Stacked above the core stage is the 12.8 meter long second stage, PS2, which uses 42 tons of earth-storable liquid propellants. The second stage of PSLV uses the proven liquid engine called Vikas engine. Over it is placed the 3.6 meter long third stage, PS3, which uses around 7.6 tons of solid propellant. This stage uses a solid rocket motor that provides high thrust after the atmospheric phase of the launch. The uppermost stage of the launch vehicle comprises 2 liquid engines. This 3 meters long fourth stage, PS4, uses 2.5 tons of earth-storable liquid propellant. Attached above this stage is the payload fairing, in which the spacecraft is housed. Realizing each launch is a Herculean task and presents challenges, both technical and logistic in nature. To meet these, ISRO over the years has nurtured a healthy ecosystem of Indian industries, which today play a major role in realization of the PSLV by manufacturing and supplying various important parts of the rocket. PSLV C-41 will be the 43rd flight of the PSLV series of launch vehicles. Launched in its XL configuration, the vehicle will lift off with the ignition of the core stage, which is immediately followed by the ignition of the 6 strap-ons 2 at a time. The booster's separation commences at about 70 seconds at an altitude of nearly 23.6 kilometers. 2 at a time, all the 6 boosters will separate from the vehicle. The core stage will separate from the vehicle at about 110 seconds at an altitude of nearly 55 kilometers. Immediately thereafter, the second stage will ignite. Around 203 seconds at an altitude of about 113 kilometers, the payload fairing will separate from the vehicle. Second stage will separate at 263 seconds and at an altitude of nearly 131.5 kilometers. The third stage will ignite at 264 seconds and at an altitude of about 132 kilometers. Third stage separation will happen at 599 seconds and at an altitude of about 183 kilometers. Fourth stage will ignite at 609 seconds and at an altitude of nearly 185 kilometers. At 1122 seconds, that is after approximately 19 minutes, the fourth stage will be cut off at an altitude of about 454.5 kilometers. Soon after, IRNSS 1I will be injected into a sub-geosynchronous transfer orbit with a perigee of approximately 284 kilometers and apogee of 20,650 kilometers. After the initial orbit-raising maneuvers, IRNSS 1I will join IRNSS constellation to provide the navigation services. Like its predecessors, IRNSS 1I has two types of payloads: navigation payload and the ranging payload. The navigation payload, operating in the S and L5 bands, transmits navigation signals to the users. The ranging payload comprises of a transponder which is operated in CDMA mode for two-way range measurements. The IRNSS satellites continuously emit timestamp navigation signals, which are received by the ground-based user receivers. The information is then processed by the receivers to derive their own position, velocity, and time. The system provides seamless 24/7 services under all weather conditions. NAVIC, the Navigation with Indian Constellation, is the Indian Regional Navigation Satellite System aimed at providing reliable navigation services. The system has been developed for providing accurate information on the position, velocity, and time to the users. It provides position accuracy better than 20 meters over Indian landmass and in the surrounding region extending to about 1,500 kilometers from its boundaries. The navigational application services enabled by NAVIC will be highly useful and provide long-term benefits to all its users, be it the common public or the advanced users like railways, airlines, maritime operators, strategic users, and many others, thus contributing significantly for overall national development.